Hey, you're back. Glad you could make it. You obviously had a good experience with your first learning card, so let's do some more. Anyway, learning card number 2 today. So we'll put a 2 up here. Learning card for solving special cases. Dun dun dun. Because let's face it, most of the time, everything's fine. Maybe an answer gets messy, but it's still an answer. You double check your work, everything's good. Sometimes something goofy happens, and that's what we're going to talk about today. So the key to this, see what I did up here? That's how much I care about you guys. Right there. Oh, that's not a bad good job coloring it. Anyway, so we got a key here. And the key to special cases is that special case solutions always happen when the variable disappears, aka zeroes out. Okay? Sometimes you're going to go along and the variable just goes away. So the question is, now what? First thing to do first is to make sure you're not making any silly mistakes. Always double check your work. Rule number 73. Well, probably close in the top 10 of math. Double check your work. But anyway, so let's talk about this, and we're going to talk about how you interpret this. So if you ever see this, refer back to learning cards, and away you go. What's going to happen here in terms of the interpretation is going to be true of any equations that you're solving, whether it be linear like we're doing now, quadratic, exponential, whatever. Okay, so this is one of those truths that are going to be true no matter what. Okay, and I'll remind you of that later. So we know our steps from our previous learning cards. See the line right there. So we're going to distribute stuff out. So everybody gets a 2 in the parentheses. 6x minus 8 is equal to 6x minus 1. Now, I move the variables first. If you don't, I'll show you both. If you don't do it that way, you still get the same answer. So I would do, I'm going to subtract 6x. Now, these go away. 6x, the whole goal is I'm moving this, so I know that that's going to zero out. So that's not a surprise. Equals, and then you're over here and you're like, wait a second. That goes away too. Okay, 6x minus 6x is 0. What's the point of that? And so then this is just going to come around and get minus 1. And you're like, wait a second, that makes no sense. So again, go back and double check your work. Make sure that you did, make sure you did your multiplication here correctly. Make sure that the numbers line up. Also make sure that the signs are, oops, wrong one. Make sure that, I've got positive and positive over here, or negative, because sometimes if one's positive and one's negative, mistakes can happen. But anyway, we did all of that. So this is false. Now to show you that it works the same way both ways, let's say if we had cleared the 8 first. So again, I'm just going to rewrite what we just did after the distribution step. Because I know some of you like to clear this off first. And you might be like, oh, let's add 8. So I get 6x is equal to 6x plus 7. Subtract 6x from both sides. Now in this case, I have 0 equals 7. Sometimes people are tempted to write down 0x there, or nothing. And that's the reason why I'm showing you that one. But again, notice this is also false. Okay, so if the variables disappear and you get a false statement, so the interpretation of this is that a false result means there's no solution. It can't exist. So no solution exists. It's that simple. Oh, I know. Stop yelling at me. It's a sentence. I should start with a capital. There. My apologies. Now what happens if that doesn't happen? Let's take a look. So again, we're going to distribute stuff out. You should at this point already have a feeling like, ew, I have 5x on one side and 5x on the other. How could this possibly turn out okay? But just don't go write no solution, because sometimes that's not the case. And I'll show you why. So, remember, simplifying each side, so then this is going to be, I'll go back to red, sorry. 5x minus 7 is equal to 5x minus 7. It's the same thing. So right now you say, hey, that's true, that makes sense. But let's say you're in that mode of just getting the right answer, so I'm going to subtract 5x off. So now I have, so that goes to 0. That goes to 0, so now I have negative 7 is equal to negative 7. Wait a second, where did my variables go? You double check your work and you see that that's true. And here's the crazy thing, okay? If you plug in any number in for x, so let's say if x equals 10, okay, 5 times 10, I can't write. If I had the time to edit this, all of this would go away. So 5 times 10 minus 7 is equal to 5 times 10 minus 2 plus 3. So if I do this, I get 50 minus 7, I get 43. Over here, I get 5 times 8 plus 3. So that's going to be 40 plus 3, which is 43. That's going to hold true for every number that you plug in. And the reason why that works is this step right up here, because when the x's go away, whatever that value was is matched over here. And what's left is a true statement. And so what this allows to the interpretation here is that if you get a true result, that means any number works. So what you're going to say is all real numbers are solutions. Okay, so if the variables disappear, you get no solution. So if it's a negative, I think of it this way. So if it's false, no solution. So it's kind of like false, it kind of has a negative connotation, so you have no solution. True means that you get all real numbers. And again, as I said, that's going to work for any equation that you're trying to solve, whether it has squared terms, non-squared terms, square roots, whatever. The variables all disappear, and you get something that's false, no solution, true, all real numbers. Okay? As always, we'll see you in class. Stop in, get questions answered, all of that as you need to. Talk to you soon.